All right, so get ready to dive into the world of research designs, but not the kind that makes you want to fall asleep. Like, you know how researchers figure things out, like when they can't do a classic experiment?
Yeah.
Well, today, we're going to go deep into this academic paper called Unit4.pdf, and it's all about that.
Hmm.
Like, did you know that there's a whole way to figure out if things are related without proving that one causes the other?
Yeah, that's true. It's called correlational research, and it helped us uncover some pretty interesting relationships.
Okay, so for example, could researchers use this to see if my coffee habit is like actually helping me be more productive? Because that's what I tell myself at least.
Well, they could definitely study that. But you got to remember, correlation doesn't automatically mean causation. It just tells you if things are moving together, not necessarily why. Like this paper talks about stress at school and achievement, and they could find a positive correlation, meaning like higher stress, higher achievement. But it's also possible to find the opposite, like higher stress goes with lower achievement.
So you're saying it's not a guarantee that stress equals success. Wow, my whole world is changing right now. But how do they even measure how strongly these things are related?
Well, they use this thing called a correlation coefficient. It's basically a number that goes from -1 to +1. The closer it is to either end, the stronger the relationship is. And if it's 0, then there's no connection at all.
Oh, okay, I get it. Like a sliding scale of how in sync things are. But the paper really emphasizes picking the right variables and using good statistics. Why is that so important?
Because the world's full of distractions. Imagine trying to study like stress and grades while ignoring sleep or study habits or their social life. It'd be a mess. Researchers have to be really careful not to mix things up and make sure they're actually studying what they think they are.
So correlation can kind of point you in the right direction, but it's not the whole story. But what about when researchers want to find the causes, but they can't actually do an experiment? Like the paper mentions studying the effects of being vegetarian. You can't really force people to change their diet, right?
Right, that wouldn't be ethical at all. That's when causal comparative research comes in. It's like having a puzzle where you can only look at the pieces, you can't change them.
That's interesting. How does that even work?
Well, they'd compare groups that are already different, like, say, vegetarians and non-vegetarians, and look for differences in something like mental health.
So they're working with groups that are already out there,
Hmm.
but how do they know the differences from being vegetarian and not something else?
Yeah, that's the hard part. Since they're not controlling anything, it's tough to rule out other factors. There might be things affecting both diet and mental health that they haven't even thought of. The source makes that really clear.
Okay, so it's like a detective story with lots of suspects, and you got to find the most likely one. So we have correlational research checking for connections,
Hmm.
and causal comparative trying to figure out causes when experiments aren't possible. How are these two designs related?
Well, there are some similarities and differences. Just like any set of tools.
Oh, are we talking about like a research toolbox here?
Exactly. And just like any toolbox, the key is knowing which tool to use.
Okay, so let's start with what these two designs have in common. So both correlational and causal comparative are non-experimental. That means the researcher isn't actually changing anything. They're just observing. So they can't like randomly put people into groups the way you would in a real experiment.
Right? They have to work with what's already there. Kind of like bird watching. You can't control where the birds fly. You just got to watch them do their thing.
Exactly. And because of that, they often use a lot of the same statistical techniques to analyze the data, since they're both dealing with groups that already exist.
Makes sense. But where do these two approaches differ?
Well, the main difference is their goal. Causal comparative research is all about understanding why things happen, but correlational research just wants to see if things happen together.
So one is searching for explanations, and the other one is just mapping out the connections. You got it. And that difference shows up in what kinds of things they study. Like causal comparative research often looks at groups, like men and women, or people who got a certain treatment compared to those who didn't. Correlational studies are more about things you can measure with numbers. Things like intelligence or age or income.
Okay, different tools for different jobs. But even if a causal comparative study finds a difference between groups, can they really say it's because of that one difference?
That's where things can get a little tricky. Remember, just because two things happen together doesn't mean one causes the other.
Like, just because ice cream sales and crime rates both go up in the summer, it doesn't mean that ice cream makes people commit crimes.
Exactly. There's probably another reason that's affecting both. Like maybe the heat makes people more irritable and also makes them crave ice cream. So even though causal comparative designs try to find causes, We got to be really careful about jumping to conclusions.
It's like that saying, don't judge a book by its cover.
Hmm,
You might see a really nice cover and think it's a great book, but you can't know for sure until you read it.
I like that. There could be other reasons for that fancy cover, like good marketing.
Okay, so we have to be careful about what the results actually mean, but there have to be some good things about these designs, right? What makes them so useful?
Well, for one, they let us study things we couldn't ethically or practically study with experiments. Imagine trying to study the effects of, say, a traumatic event in a lab. You can't just expose people to trauma for research purposes.
Yeah, that makes sense. And this paper actually points out that these designs often use real-world data, which is really relevant for our listeners who want to understand things that happen in the real world.
Absolutely. Instead of creating some fake scenario, researchers can look at things that are already happening and try to understand them. It opens up so many possibilities.
It's like studying animals in the wild versus at a zoo, right? You get a much better idea of how they actually live.
Exactly. Plus, these designs can be a lot cheaper and faster than experiments because they often involve working with data that's already out there. You don't need to spend years collecting data in a lab.
So they're like the efficient, budget-friendly researchers.
You could say that. They make the most of what they have and still get valuable insights.
I'm starting to see why these designs are so popular in fields like psychology and education. But let's not forget about those limitations we talked about.
Right.
What are some things we need to watch out for when looking at the results?
Well, like we've said, not being able to randomly assign people to groups is a big one. It means we can't be totally sure that any differences we see between groups are because of the thing we're studying and not something totally different.
So there's always a chance that something else is causing the relationship, like that heat and ice cream thing we talked about.
Right, and this is especially true for correlational research where you have the directionality problem.
The directionality problem. Sounds serious. Tell me more.
Basically, it means we can't always tell which variable is influencing the other, or if they're both being influenced by some other hidden variable.
Like trying to untangle a knot, but not knowing where to start.
Exactly. Like, say a study finds that people who exercise a lot are less likely to be depressed. Does exercise prevent depression? Or people who are already less depressed just more likely to exercise? It's kind of a chicken and egg situation.
I see. So that's where those fancy statistical techniques and choosing the right variables come in handy.
Yeah, definitely. They can help us address some of these problems, but we still got to be aware of them and be careful about how we interpret the findings.
It sounds like these research designs are kind of like doing a puzzle, but with some pieces missing. You can get the general idea, but there's still some gaps.
That's a great analogy. It really shows how important it is to be humble and not overstate what we know.
So even though these designs can't always give us clear answers, they can still give us valuable clues and lead to new discoveries. It's pretty cool how researchers can adapt their methods to tackle all these different kinds of questions.
Absolutely. It shows that research isn't just about following some strict rules. It's about finding new and creative ways to learn about the world.
Well said. You know, I'm already starting to see the world differently. Like I'm noticing connections and patterns I never really thought about before. This deep dive is really making me think like a researcher.
That's great to hear. And remember, even though these designs have some limitations, they offer a really powerful way to understand the world, especially when we can't do those traditional experiments.
Okay, so we talked about all the basics of these designs, but now I'm curious to see how they're actually used. Can you give us some examples from the real world?
Sure, let's get into some examples. Say you're interested in how screen time affects kids' development. You wouldn't want to randomly assign kids to have different amounts of screen time, would you?
No way, that would be chaos. You'd have some pretty upset parents and some very unhappy kids.
Exactly. So researchers might use a correlational design to look at the relationship between screen time and things like language skills or how well they socialize or their attention span.
So they could see if there's a link between how much screen time kids get and how they're developing in those areas.
Yep, exactly. And they might find that kids who have more screen time tend to score lower on language tests. Or maybe they find no relationship at all. Either way, it gives them some useful information about how these things might be connected out in the real world.
That makes sense. What about an example for causal comparative research?
Okay, let's say researchers want to study the long-term effects of different types of preschool. They could compare kids who went to a play-based preschool versus those who went to one that was more academic, and see how they differ in things like grades or social skills when they get to elementary school.
Oh, so they're looking at kids who are already in those programs. That's smart.
It is, but we got to remember, even if they find differences, they can't say for sure that it was the preschool that caused them. There could be other things going on, like family background
Yeah.
or just individual learning
Right.
styles.
We can't forget about those limitations. But it's still a really cool way to learn about those programs out in the real world. This whole deep dive has been eye-opening. These research designs are so powerful, even with their limitations.
Yeah, they really are great tools for exploring these big questions. And that's what this paper is all about, thinking like a researcher.
I love that. It makes me realize that research isn't just something that happens in a lab or at a university. It's a way of thinking, a way of looking at the world with curiosity, wanting to understand how things work.
Exactly. And the source actually poses a question to the reader. It says, if you were a researcher, what would you want to study using these designs? What kind of ethical or practical challenges might you run into?
That's a great question. What would I study? Maybe the relationship between having pets and stress levels. I've always felt like having a furry friend helps me relax. But I wonder if there's any real evidence for that.
That's a perfect example. You could even use a causal comparative design. Compare the stress levels of pet owners and people who don't have pets, while taking into account other things that might affect stress.
This is getting me all excited about research.
Yeah.
I'm seeing research possibilities everywhere now.
That's what it's all about. Once you start thinking like a researcher, the whole world becomes a lab, full of interesting questions just waiting to be answered.
Well, this deep dive has definitely given me a no respect for researchers. They're so creative and resourceful. It's amazing how they can use these different approaches to tackle tough questions and make new discoveries.
For sure. And remember, research never really ends. There's always something new to learn, more questions to ask, and more mysteries to solve.
Well said. So to all our listeners out there, stay curious, keep asking questions. And who knows, maybe you'll be the next researcher to make a big breakthrough using correlational or causal comparative research. Thanks for joining us on this deep dive. And until next time, happy researching.
Thanks for watching. If you found this video helpful, don't forget to give it a thumbs up and share it with your friends. Your support helps us keep creating valuable content like this. And if you haven't already, hit that subscribe button and ring the notification bell so you never miss an update. Join our community for more insights into psychology and personal development. Let's grow and learn together. See you in the next video.